Hi everyone, and welcome back to this series of short videos devoted to CytoPipeline, another tool for building and visualizing pre-processing pipelines for flow cytometry data. In this video, we'll focus again on visualization, and here we will compare two different runs of pipelines, including different methods of quality control. Quality control meaning focusing on the stability in time of the signal. So let's get started. And so let's now create a new pipeline object, so CytoPipeline, using Flow AI as a QC method. So with Flow AI, we are going to basically focus on the quality control. So this is a competitor of PicoQC. However, PicoQC needs to run on scale transformed and compensated data, while Flow AI can perfectly run on raw data. So this means that in terms of the order of the steps in the pipeline, the Flow AI pipeline will be a bit different from the PicoQC pipeline. And so in order to reflect this, we will create a new JSON file to specify our new pipeline. And this JSON file is going to be called HBVT demo pipeline flowai.json. And so in this, what we can find is the same kind of steps all over again. But now we have a perform QC step, which is basically slightly different than before. So now calling a function which is called quality control flow AI, where the arguments correspond to the parameters of the flow AI methods. Okay. Again, this step can be run much earlier than in the case of the Pico QC. And so the compensation here is not before the QC, but is run at the end of the pipeline after the QC. So we have the compensate part. In terms of scale transformation, we use pre-transform equal false, meaning that the Flow AI package will be called on untransformed data. So this is a bit different from what was done in the Pico QC pipeline, where basically the perform QC was at the end and using transform equals true. Okay, so now using this new JSON file, we can create a new object, and we use a new experiment name as well, so HBVT demo flow AI, and using the same sample files as before. So let's create the object. Now visualize, so show the object, and we can see indeed that we find back the flow AI step here, and then we can execute our new pipeline. So again, the same process is happening here. It will take a few seconds to execute. So it is now running on the first sample file and now already running on the second sample file. Okay. And this is about to be done, and this is done. So let's check the state of the workflow using plot CytoPipeline processing queue, and again, everything has run correctly. We see all the bubbles are green. Okay, and now let's visualize our results using our Shiny application. Okay, so let's first focus on the Pico QC again, the QC part of the Pico QC pipeline using the 2-cluster version that we created before. And now have a look for once at the second sample file. Okay, we can see the order of operations and look at the comparison. So let's see what happens between the compensate step and the perform QC with Pico QC here. And so for the visualization of the quality control, so looking at time dimension, it's better to basically not use a fixed linear range and use all the sample events. It's more clear. So let's select on the x-axis the time, and on the y-axis any channel could do. Let's select the first one, FSCA. And so, yes, what we can see is this is before the QC step, and we can see that there is kind of a hiccup here, so a jump in the distribution characteristics. You can see clearly that there are more points and a higher variance here. However, Pico QC has not eliminated any events. Remove 0% of events. So Okay, it seems that PicoQC has not detected any issue with the signal itself. Maybe it is right, but okay, it's a bit weird in that case. Let's now have a look at what our pipeline with FlowAI has done. Okay, using also the same sample file, second sample file, and now have a look at, so the order of steps is a bit different, so let's flag the correct steps. Okay, and here we can see that FlowAI has eliminated a big chunk here around this very tiny interval. Okay, so FlowAI is looking to keep distribution of the signal in time as constant as possible. So it seems that this part has a distribution which might be similar to what was before and what was after. Okay, as we can see. So we can see here a difference. Now, in a real life example where we have different steps and so on, it is interesting to compare the two different pipelines altogether. And so comparing PicoQC with FlowAI on the same sample file, and then since they are a bit different in the order of operation and so on, have a look at the very last step, so looking at the outcome of the whole pre-processing. And in order to do this, we will select the last steps in both pipeline. I think there is an issue here. Yes, I need to select the FlowAI here. Okay, so perform QC is correct, and here we'll take the compensate, the very last step. And so this is the outcome between, so the comparison between PicoQC at the end of the process and FlowAI, and we can really see that this is in fact, the number of events are different, and this step of QC is responsible for the difference between the two different pipelines. Now we can also check this on the first sample file and see whether we have the same kind of issue. Yeah, it seems that for the first sample file we did not have this hiccup, and so the difference between the different pipelines is much more minor, and it seems that FlowAI has eliminated a bit, some very tiny chunks, but not very material. So this was one example of comparing two different pipelines that are a bit more different than the previous example that we gave. And that's it. So this ends up the part on the visualization of the different flow frames that constitute the intermediate results of a CytoPipeline run. In the next video, we are going to focus on another part of the visualization, which is devoted to the scale transformation.